So we have got the expression of velocity of ball with respect to trolley as this. If this is the expression of velocity, then the angle which the velocity vector is making with x-axis, that would be this. The y component, the j component upon the x component. If velocity has two components, I and j, then this is the resultant velocity vector, and the angle which it is making with the x-axis, tan theta of that angle, tan of that angle, is perpendicular upon base. This is y component upon x component. So this is tan theta. So we have got the tan theta of this. And now there is also one more constraint in the problem, that the ball is going to hit the trolley. If the ball is going to hit the trolley, and if phi is the angle which the ball is making with the x-axis as it has been given in the problem in the ground reference frame, then the x component of the velocity of the ball would be v cos phi, and the displacement which the ball will have along x-axis when it's going to hit the trolley is going to be, let's suppose it is d. This distance is d. Then the time it would take would be d upon v cos phi for the ball to move by d unit along x-axis. Now since this angle is 45 degree, this angle is also 45 degree, then this distance is also d. So the displacement which the ball is going to have with respect to trolley will be d. If the trolley moves by a certain distance, then the ball, in order to hit the trolley, will have to go that certain distance plus d, because ball is starting from origin. So the relative displacement of the ball along y-axis is also going to be d. And the relative velocity of the ball will be the velocity of the ball minus velocity of the trolley. Velocity of the ball along y-axis is v sin phi minus velocity of the trolley, which is given. Fine. So it will have a displacement of d along x and displacement of d along y relative to the trolley simultaneously when it hits the trolley. So these two time taken would be the same. So from here you can see that this expression from here you can see is 1. This is equal to 1. That means tan theta is 1. Theta is 45 degree. So the angle which the velocity vector is making from the trolley reference frame is also 45 degree. As we have got the same answer from the previous discussion using intuition. This is a mathematical proof of that. Okay, now you got 2 marks for that. We'll move to the second part of the problem. Second part of the problem says, it actually asks you to find the velocity of the ball with respect to ground if it grants you that phi is 4 by 3 theta. Theta is the angle of the ball, velocity vector of the ball with x-axis from the trolley reference frame as was given in the previous part. And phi is the angle of the velocity vector with x-axis from the ground reference frame as been given in the previous part. So now they are saying, they're making things very easy. They're giving you that phi is 4 by 3 of theta. Then find the velocity of the ball. Velocity of the ball was not provided. They're asking you now to find it out. That will give you 3 marks if you find a velocity of the ball in the reference frame of ground. So you have to fight for this 3 marks really. Okay, theta you have found out as 45 degree. The phi will come out as 60 degree. Now there is one equation of constraint here, and that is d upon v cos phi is equal to d upon v sin phi minus root 3 minus 1. Fine, as we discussed in the previous part. So from here we can see that what we have got is v sin phi minus cos phi is equal to root 3 minus 1. This is what we get from here. Now phi comes out as 60 degree. That means sin 60 degree root 3 by 2 minus cos 60 degree half is equal to root 3 minus 1. From here you easily get velocity of the ball in the reference frame of ground is 2. The unit would be whatever the unit was given in the problem, meter per minute or meter per second. Okay? Okay, so that gives you 5 marks. So what are your feelings now? Was it easy for you? If it was easy for you, then things are easy for you. You've got it. Relative velocity up till now. Okay, now what you have to do now at this stage, you should really recapitulate what you have studied in relative velocity, and you should make a proper note of it, and you have to make a very concise note, exactly what you studied, and the rest of the thing is just detail. What is it that comes out of the study of up till now, whatever we have done up till now? So make a note of the most important thing that you have studied, and I think what you have studied is just this. Velocity of A with respect to B is velocity of A minus velocity of B. We have played around just with this. And you should really also sit down and regarding the river problem that we did, you should analyze what will be the situation in which the man or the swimmer is going to go straight to the opposite end, and what will be the condition in which the man is going to travel to the other end fastest in the minimum time, what will be the condition in which the drift of the man will be minimum. I mean, analyze all these three and have a good practice of that. If you're comfortable with whatever we have solved up till now, you'll be comfortable with whatever you're going to get in the exam. And to have a more practice, you have an exercise waiting for you. Do a good recapitulation of what you have studied up till now and go and solve the exercise. Okay?